Today we will start with chapter 6, lesson 6, Free Fall Explained. Now, the idea from this lesson that all freely falling objects fall with the same acceleration because the net force on an object is only its weight, and the ratio of, weight to mass is the same for all objects. So, if there's an airplane fall down or there's a ball fall down, both of them have the same acceleration. Why? Because the ratio of the weight of the airplane to its mass, it's like this. The ratio from the weight of the airplane to its mass is or equals the ratio from the force of the ball to its mass. So recall that mass, which is the quantity of matter, and weight, which is the force due to the gravity, are proportional. Let's say that, or let's recall that the mass, which is the quantity of matter, and we said that the acceleration, all of us know the acceleration is a force over mass. So what is the force that's acting on a falling down object? It's only the weight. And the mass, we know it, which is the quantity of matter. So F stands for the force, which is the weight acting on a cannonball, and M stands for the corresponding large mass of the cannonball. The small f and m stand for the weight and mass of a stone. So here, as I told you, not cannonball, let's say that we have an aeroplane, let's say, and here, and there's a stone. The mass of the plane is very large. So its weight, it will be very large. This is the force, or we say it is the weight. Its weight, it will be very large. So, and the stone, the mass of the stone is very small, and its weight, it will be very small. But the ratio of the weight of the plane to its mass equals the ratio from the weight of the stone to its mass, which is equal 10. So all freeing objects undergo the same acceleration at the same place on Earth. So it doesn't matter if there's a plane, if there's a cannonball, if there's a small ball, if there's a stone, any object falling down as it sorry, any free falling object undergo the acceleration with any mass, it will have the same acceleration. So the ratio, this is the important thing from this, or this is the important statement from this lesson, that the ratio of weight to the mass of any object will be the same at any place for any object. So here, the ratio of weight F to mass M is the same for 10 kilogram cannonball or for 1 kilogram stone. So teacher, how? We know, let's find the weight or the force, which is the weight of the cannonball. The weight is M times G, which is 100. So here I will write 100 over 10. 10, which is the mass, the weight, which is 100. That's we found it here. Now let's find the force of the stone now. It is the weight of the stone. I told you that the only force that's acting on any object that's falling down is its weight. So its weight, which is 1 times 10 by mg equal 10. So here it is 10, the force or the weight of the stone, over its mass 1. Now let's divide. 100 over 10 is 10, and 10 over 1 equals 10. So the ratio of the weight of the stone to its mass equals the ratio of the cannonball to its mass, which is equals G. Is it clear?
Yeah.
Yeah.
Let's have an example here. The weight of 1 kilogram stone is 10 Newton at Earth surface. Using Newton's second law, the acceleration will be. They told me that if the force is 10 and the mass is 1, so let's find the acceleration. We say the acceleration is F over m, weight over the mass. The weight is 10, the mass is 1. So 10 over 1, it will be 10 meter per second square, which is the gravity. And the weight of 10 kilogram, this is the mass, and the force, which is 100, equals also 10, which is the gravity. So the acceleration of the stone will be the acceleration of the cannonball.